All right, AP class, let's get ready to get into it. What we're looking at here is an ice problem, and this ice problem has the K value right over here, and there we go, and does not have any equilibrium concentrations, which we're going to have to find. So we have the initial concentrations of both reactants at 0.2 and 0.2 and 0. So this right here is the initial. The change is what I'm going to explain next, and then the equilibrium is what obviously we're going to find. So here's how this works. For an ice problem, the reactants are going to decrease in concentration by some amount. Notice that there is ones in front for coefficients, so they're going to decrease by the same amount like that, minus x and minus x. That means for the equilibrium concentrations, I can be reasonably confident that 0.20 minus x is what my equilibrium concentration for Br2 is going to be, and guess what? The same for my Cl2. Now, on the other side for the product, I'm always going to be adding x, but in this case here with the coefficient, it's actually going to be 2x. And since 0 plus 2x equals 2x, then my equilibrium concentration for BrCl is going to be 2x. So now, excuse me, you guys know that my K value would look something like my concentration, my K expression, I mean, that's for bromine monochloride is squared because of the 2, and then I have the concentration of Br2 times the concentration of Cl2. This is for equilibrium, okay? So I do know my values for equilibrium. They are 0.2 minus x, 0.2 minus x, and 2x. So when I plug them in to this K expression, what I end up with is 2x, the whole thing squared, over 0.2 minus x times 0.2 minus x, like that. And all of that equals 7.2. Any questions so far? All I have now is an algebra problem where I'm finding x. Okay, not a good one. This is an awful algebra problem, and I understand those people that hate algebra because of problems like this, but all this is an algebra problem. Now, here's what I notice. I notice the two reactants are both the same for the equilibrium values, okay, which means that if I need to, I can consider them to be, now sometimes this happens and sometimes it doesn't, but if I needed to, I could consider them to be the same, like that. Okay, everybody understand what's going on there? I just combined those two to be squares. Why'd I do that? Well, let me tell you. One easy way to do this would be to take the square root of both sides, like that. And then what I end up with is 2x over 0.20 minus x equals, and now when I type in 7.2 square root of that, I get 2.683. Okay, I just made my algebra problem a lot easier. So I multiply both sides by 0.20 minus x to get this off the bottom, like that. Excuse me. And what I end up with then as I continue on is this one becomes, I need more room. So I got 2x equals 0.5367 minus 2.683x, like that, when I multiply here and there. And then I get, to get 2.63x on the other side, I add 2.683x to both sides to get 4.683x equals 0.5367, like that. More room, more room, more room. There we go. So once I get this point here, now I can just divide through by this. This is just algebra. That's all I'm doing. We're not doing anything fancy, no calculus, no new concepts. Once I get to the equation, the ice problem is actually finished, and everything after that is algebra. So I'm going to divide here this number, the 0.5367, divided by 4.683, and what I get then is 0.11459. So I'm just going to round that off to 0.115. That's my x. So what was the original problem asking? I think it was asking up here for what is the equilibrium concentration of that? Well, as you can see, it's 2x. And if it's 2x, then 2 times 0.115 equals, 0.230 as my concentration. Okay? That would, of course, make each one of these then 0.2 minus 0.115 equals 0.085 and 0.085 for equilibrium concentrations. Okay? And that's how you do that problem. Boy, that looks busy, doesn't it? All right, that's the practice problem. Thank you for following along.